AI development infrastructure and optimization. The economics of GPU utilization are finally getting the scrutiny they deserve. Anyscale recently published data revealing that most production AI clusters operate at less than 50% GPU utilization, a staggering inefficiency when those clusters are packed with $50,000 H100 accelerators sitting idle between traffic spikes. The culprit is the cold start problem. Current cold starts take 30+ seconds, making it impractical to spin down GPUs during low traffic periods. Users abandon requests after 5 to 10 seconds, so organizations are forced to keep expensive infrastructure running continuously. Anyscale's proposed solution is disaggregation via their Ray framework, splitting CPU logic from GPU logic to saturate GPUs more efficiently through sophisticated scheduling. But a competing approach from the InferX project argues this is over-engineering a physics problem. Their thesis: if model loading could drop from 30+ seconds to under 2 seconds using system RAM tiering and PCIe saturation, complex schedulers become unnecessary. The project demonstrates hot-swapping models from RAM in approximately 1.5 seconds on consumer RTX 3090 hardware. When challenged on whether this was achievable given PCIe Gen 4.16's theoretical maximum of 31 gigabits per second, the developers confirmed sustained transfers of 24 to 25 gigabits per second using a custom pinned memory allocator that bypasses standard torch.load overhead. Nothing is permanently pinned on the GPU. Models live in system RAM and transfer only when needed. The practical implications of these infrastructure challenges become vivid when examining real-world deployments. A solo developer tasked with deploying Open Web UI for approximately 2,000 users, primarily social workers at a local authority in Europe, sought community guidance on architecture decisions. The consensus from practitioners who had scaled similar deployments was unambiguous. Start with multi-replica architecture from day one, as retrofitting is far more painful. One respondent who had scaled to 2,000 users on OpenShift reported that a single pod literally cannot handle the concurrent traffic, API orchestration, and memory pressure of 2,000 users. Beyond basic scaling, the deployment discussion revealed nuanced operational wisdom. SSO OIDC integration was described as seamless, worked out of the box, zero issues. But user adoption reality proved humbling. Even with training, many users remain reluctant to engage with AI tools. The most critical advice centered on establishing a coherent group strategy before launch, with one practitioner noting their groups synced from identity providers are a mess, and that planning MCP servers and tool connections beforehand would have saved considerable pain. These infrastructure debates, whether about GPU scheduling philosophy or practical deployment architecture, reflect an industry moving from proof of concept to production-grade systems where efficiency and reliability actually matter. AI-powered development tools and code generation. The trajectory of AI coding assistants over the past year tells a sobering story about the gap between ambition and capability. Remember Devon? When it launched, commentators predicted the end of software engineering jobs. Now it's radio silence. The pattern emerging from developers who actually use these tools is consistent. Devon didn't fail because the ambition was wrong. It failed because it aimed at a version of autonomy that current models and tooling simply cannot support. You cannot expect a single system to understand your repository, rewrite your backend, run migrations, and ship a product without substantial human constraints. The reality of working with AI coding agents, as practitioners describe it, involves considerable babysitting. You assign a task, the agent goes off the rails, you correct it, it sort of gets back on track, and the cycle repeats. This feels less like replacing engineers and more like managing a really fast, sometimes frustrating intern. The industry response has been a pivot toward more realistic tool design. Cursor doubles down on code editing, Claude builds reasoning chains, DeepSeek pushes speed and cost efficiency. Multi-agent structures like atoms break problems into parts and communicate progress, rather than one giant agent guessing at everything. The emerging wisdom: the future isn't a single autonomous agent, it's systems that work with humans rather than attempting to replace them. This shift toward collaboration over replacement has spawned a cottage industry of tools addressing specific pain points. Claude Cortex, for instance, tackles the frustrating reality of context compaction. Those moments when you're deep in a Claude code session, having made crucial architecture decisions and established patterns, only to have everything vanish when the context window compacts. The tool implements a brain-like memory system with short-term session memory, long-term cross-session storage, and episodic memory for successful patterns, all with salience detection to auto-identify what's worth preserving. Its pre-compact hook extracts important context before compaction occurs. Governance and security concerns are maturing alongside capability improvements. The idea of building virtual file systems for Claude Code addresses enterprise deployment requirements that MCP, Model Context Protocol, doesn't yet solve. Controlling data and tool access, providing shared context across agents, maintaining audit logs, and managing permissions. The concept treats integrations like Gmail and GitHub as directories. Mount workspace/gmail/unread, and your agent can ls and cat emails with permissions handled via familiar Linux file permissions. Models already understand POSIX, and IT teams already understand file permissions, making this an elegant governance layer. Security monitoring is becoming essential as agent autonomy increases. Moltbot, formerly ClaudeBot, recently began forcing gateway authentication tokens by default, even for loopback-only setups, likely in response to a surprisingly high volume of exposed banners appearing on Shodan. The deeper question remains, what stops an agent with deep system access from changing its own security settings, whether through self-preservation instincts, naive attempts to help more users, or prompt injection attacks? Similarly, Nova Protector provides visibility into agent actions by leveraging Claude Code's hook system to trace file reads, command executions, MCP server calls, and skill invocations. The tool integrates adversarial prompt detection for instruction overrides, roleplay jailbreaks, and encoding obfuscation attacks. Meanwhile, Git AI has emerged as an open-source extension for tracking AI-generated code through the entire software development lifecycle. Rather than attempting to detect AI code after the fact, described as an anti-pattern, Git AI has coding agents declare exactly which lines they generated, storing this attribution in Git notes that persist through rebases, merges, and cherry picks. The world is and will continue to be multi-agent. Git AI is designed to be vendor agnostic and open, giving developers ownership of their AI usage and prompt data. Open source model releases and comparisons. Moonshot AI's Kimi K2.5 represents a significant step forward for open source visual and agentic intelligence. The model weighs in at 1 trillion total parameters, with 32 billion activated, a mixture of experts architecture that keeps inference manageable while enabling impressive capabilities. Built through continual pre-training on approximately 15 trillion mixed visual and text tokens on top of Kimi K2 base, this brings total training to roughly 30.5 trillion tokens, nearly double the original pre-training, representing substantial work beyond just supervised fine-tuning and reinforcement learning. The benchmark results are genuinely impressive. On agentic benchmarks, K25 achieves global state-of-the-art with 50.2% on HLE full set and 74.9% on BrowseComp. For vision encoding among open-source models, it leads with 78.5% on MMMU Pro, 86.6% on VideoMemu, and 76.8% on LE Bench Verified. Independent testing on Lineage Bench shows K2.5 scoring 0.963 overall, a dramatic improvement from K2 Thinking's 0.525, with community members noting it has joined the elite Reasoners Club. For creative writing, it ranks as the top open model on EQBench long-form writing benchmark, with users reporting grok levels of uncensored content and decent prose quality. The Agent Swarm feature deserves particular attention. Currently in beta for high-tier users, it enables up to 100 sub-agents working in parallel with up to 1,500 tool calls, running 4.5 times faster than single-agent setups. Community discussion noted that the primary purpose of sub-agents is protecting the primary model's context window from overload. Well-coordinated sub-agents can accomplish substantially more than a single agent for reasonably parallel tasks. The Code with Taste visual coding feature can transform chats, images, and videos into aesthetic websites. At the 60 GB storage class, developers are actively comparing newer entrants for coding tasks. The emerging consensus places Minimax 2.1 and GLM 4.5 Air at the top, with DevStrawl 2 small and GLM 4.7 Flash roughly equal, though DevStrawl excels at math, physics, while Flash handles creative design better, followed by GPT OSS 120B and Qwen 3 Coder 30B. GLM 4.7 Flash in particular shows strong tool calling and mixed language coding capabilities, with one user reporting excellent results combining Ollama with GLM 4.7 Flash 4 with Claude Code for front-end and back-end work with Golang and gRPC microservices. However, it reportedly struggles with complex agentic multi-step tooling harnesses. Research continues pushing the boundaries of what's possible with ensemble approaches. A new paper on mixture of models introduces the N-way self-evaluating deliberation (NSED) protocol, treating model selection as a variation of the knapsack problem through a dynamic expertise broker. Unlike traditional MOE systems with static gating networks, NSE formalizes deliberation as a recurrent deliberation topology with a semantic forget gate enabling iterative refinement without proportional VRAM scaling. The key finding: ensembles of small 20B parameter consumer-grade models can match or exceed the performance of state-of-the-art 100B plus models. With an empirical utility model showing ROA equals 0.97 on test data, this characterizes consensus as a trade-off between signal extraction and contextual noise accumulation. Looking back at the catalyst for much of this progress, a Hugging Face retrospective marks 1 year since the DeepSeek moment, when DeepSeek's R1 release fundamentally reshaped the open-source landscape. R1 lowered 3 critical barriers: technical, openly sharing reasoning paths and post-training methods; adoption, MIT licensing enabling straightforward use and modification; and psychological, shifting the question from "can we do this?" to "how do we do this well?" The top-liked models on Hugging Face are no longer majority US developed, and reasoning has become a reusable engineering module rather than a locked capability behind closed APIs. The open-source momentum continues with focused releases. Qwen Image 2512 represents a significant update to text-to-image generation, with over 10,000 rounds of blind evaluation on AI Arena, demonstrating it as the strongest open-source model in its category, highly competitive even against closed-source alternatives. Improvements include enhanced human realism, finer natural detail, and better text rendering within images. Qwen 3 TTS expands into speech with a system supporting 10 major languages, featuring end-to-end latency as low as 97 milliseconds through a dual-track hybrid streaming architecture. Agent CPM report, meanwhile, claims Gemini 2.5 Pro deep research level performance with just 8 billion parameters, generating long-form reports through an average of 40 rounds of deep retrieval and nearly 100 rounds of chain-of-thought reasoning. Local AI hardware and implementation. For enthusiasts seeking to add local AI capabilities alongside existing workflows, GPU selection advice reveals practical trade-offs. A user with a 3090 Ti wanting to run local prompting while simultaneously running comfy UI image generation asked about 8 to 12 GB secondary GPUs. The responses were instructive. A 3060 Ti with 8 GB runs Qwen 4 BVL adequately, analyzing images in about 5 seconds, though 3090s run approximately twice as fast. For vision LLMs with decent context, the advice was stark. DevStrawl Small fits poorly with limited context on a single 3090, so consider getting another 3090 entirely. This reflects the persistent tension between budget constraints and the ever-expanding appetite of capable models. The push toward edge deployment continues advancing. A new open-source React Native implementation demonstrates on-device tool calling with Llama 3.2 3B on iPhone, successfully suggesting sushi restaurants, a practical demonstration of local AI moving beyond simple chat toward actually useful agentic behavior. At the opposite end of the complexity spectrum, Gemma 3.c proves that modern LLMs can run without Python, PyTorch, or GPUs entirely. This pure C implementation for Gemma 3 features 0 external dependencies, supporting grouped query attention, hybrid attention, and Swiglu activations. The 4B model requires approximately 8 GB on disk in BF16 format. As the project tagline puts it, if you ever wanted to see Gemma 3 breathe in pure C, this is it. AI impact on content and data systems. The intersection of AI and content systems is creating both new possibilities and new pressures. OpenStreetMap has found itself overwhelmed by bots scraping data. The tweet's brevity belies a serious infrastructure concern. As AI systems increasingly require fresh training data, community-maintained resources become attractive targets for automated harvesting at scales their volunteer-maintained infrastructure never anticipated. On the content creation side, LLM-generated newspapers are emerging as a demonstration of niche publishing taken to its logical extreme. Rafael Ben-Ari has built 2 fully AI-generated papers: a tech newsfeed focused on the AI industry, and a retro computing paper based on SimCity 2000's internal newspaper aesthetic. The system uses OpenCode to manage multiple AI agents serving as both reporters and editors, each in separate sandboxes. This architecture enables varying the model by agent, potentially handing some tasks to small locally run models to save tokens for computationally intensive work. The implementation reflects a broader pattern. Rather than one monolithic model doing everything, orchestrated multi-agent systems can assign different tasks to appropriate models. With the right prompting, you could theoretically produce a publication with exactly the topics that interest you and none that don't. The Hackaday author notes, with dry humor, that you could use this toolkit to replace your daily dose of their publication. But we really hope you don't. We'd miss you. The comment section captured the tension well. Some see this as one of the better LLM applications, while others question the containerized sandboxing approach, noting it's the same LLM behind the scenes, just wearing different hats. The counter-argument holds that passing text through multiple passes with different prompts, you're an editor, you're a reporter, does yield genuine improvement by allowing later context to affect earlier outputs in a forward-only generation system. Development tools and version control. The tooling ecosystem around local AI is maturing rapidly. Last Archive presents itself as a local-first RAG engine for web archival and semantic search, a project that lets users crawl, embed, and query their own knowledge base entirely offline. The system combines multiple specialized microservices, a high-concurrency web crawler handling HTML images and PDF documents, a transformer-based embedding service, a bridge for Llama providing OpenAI-compatible LLM inference, and a QDRANT vector database for semantic similarity search. The architecture emphasizes complete data sovereignty. Everything runs on local infrastructure without external API dependencies. The stack choices are telling: Next.js 16 with React 19 for the front end, Express with SQLite for the API orchestrator, Go for the high concurrency crawler. Built-in robots TXT compliance and controlled crawl rates suggest this is designed for legitimate archival rather than aggressive scraping. The project bills itself with refreshing honesty. It's not perfect, but it works, I guess. For developers working with AI coding agents, Roborev offers continuous, non-invasive background code review. The tool works with major agents including Codex, Claude Code, Gemini, Copilot, and OpenCode, providing immediate critical feedback on every commit via Git hooks. Reviews happen continuously in the background, with a TUI featuring Vim-style navigation and real-time review queues. When reviews fail, AI can automatically address the issues. For teams wanting to track this across multiple machines, PostgreSQL Sync is available. The focus on being non-invasive reflects a mature understanding that developers don't want tools that interrupt flow. They want feedback available when they're ready to receive it.